హలో చక్రధర్ గారు. హలో చక్రధర్ గారు.
సరే సార్.
ఓకే, వాయిస్ వినపడుస్తుంది కదా?
వినిపిస్తుంది సార్, వినిపిస్తుంది సార్.
ఓకే, ఇది వినిపిస్తుంది. ఒక 5 minutes స్టార్ట్ చేస్తారు సార్.
ఓకే సార్.
రాజు గారు మీరు లైన్లో ఉండండి. సార్ గుడ్ ఈవినింగ్ ఆల్ ఆఫ్ యూ. ఐఎమ్ కమింగ్. सर ये लिंक मेरे भेजो सर ये लिंक मेरे फॉरवर्ड करो. Sir, good evening all of you. Just we came from Chief Secretary, just waiting for 5 minutes. Kindly excuse.
Good evening.
Good evening.
Chairman sir, good evening.
Coming from Chief Secretary, sir, just heavy traffic. We will join in a few minutes. Kindly excuse.
Okay, Chairman sir, okay.
Yeah, kindly Manager Dr. Marigaru, we are coming.
Yes, sir. Okay. Please come, no problem.
Sir, sir.
Yeah, we'll start in once Chairman is on the way, is reaching within 5 to 10 minutes. We'll start there. Please bear with us. Karim sir, how are you?
Thank you, sir. We are also coming along with him.
Oh, very nice.
Oh, so we'll meet you. Thank you.
Yes. Please come.
పద్మగారు ఎలా ఉన్నారు? పద్మగారు సుధాకర్ గారు
బాగున్నారా సార్?
బాగున్నాను. Very happy. 21 members joined. Okay. Understanding. थोड़ा साउंड कम कर सर. आ गया आप. या आ गया सर. अब ओके सर आ गया सर. नो नीड. आप साउंड कम कर.
Hello, good evening to all.
Good evening. Congratulations.
మీకోసం నిద్ర లేచా, నిద్ర పోలే. నిజం చెప్పాలంటే చైర్మన్ గారు ఇన్విటేషన్ పంపాక నిద్ర పోతే కష్టం అని నిద్ర పోలే.
బ్రహ్మాండ
సార్ కేఎం శ్రీనివాస్ గారు, బ్రహ్మారెడ్డి గారు. గుడ్ ఈవినింగ్ టు ఆల్ ఆఫ్ యు సార్. వెల్కమ్ యు ఆల్ సార్.
కేఎం శ్రీనివాస్ సార్, నమస్కారం సార్. డాక్టర్ ఎస్ఎన్ రాజు గారు.
ఇంకా టైం ఉందా? కొంచెం నేను వేరే ఫోన్ మాట్లాడుతాను కదా.
5 minutes మాట్లాడు సార్. 5 minutes టైం సార్. మాట్లాడండి.
5 minutes సార్. ఓన్లీ 5 minutes సార్. చైర్మన్ is sir on the way. Is reaching in 5 minutes.
పద్మజ గారు గుడ్ ఈవినింగ్.
బ్రహ్మారెడ్డి గారు,
నమస్కారం. అవును బ్రహ్మ సాబ్ ఉండగా దండ స్టార్ట్ చేయొచ్చు.
వచ్చాను స్టార్ట్ ఇట్. ఐఎస్ఎన్ రాజు గారు గుడ్ ఈవినింగ్.
సార్
వాళ్ళు చెప్పేది అలాగే జూమ్ మీటింగ్ తెలుసా?
రాజు సార్ గుడ్ ఈవినింగ్.
గుడ్ ఈవినింగ్, వెల్కమ్.
దిస్ ఇస్
కమింగ్ ఇన్ 5 minutes sir. Kindly excuse.
మేడం ఏమన్నారు ఈయనకు కాకుంటే మ్యూట్ లో పెట్టి
కరెంట్ పోయింది, మళ్ళీ ఇంకోసారి
కరెంట్ పోయింది సార్.
నమస్తే.
వాని మూడు నాట్
ఫోన్ చేయాలి.
regular. Come, we are presenting you. Come.
Hello, Mendoji. 20
half an hour. But we are
Mendoji, how are you?
Yeah.
సెక్రటరీ కూడా వస్తున్నారు.
Ramareddy sir, good evening. Hello, Mendoji. Mari Ramesh speaking. Mendoji, how are you? Gilidhar sir. Good evening.
సత్యనారాయణ కూడా మన ఆఫీస్కి వచ్చారు రండి.
వచ్చారు.
Good evening.
Good evening.
గుడ్ ఈవినింగ్.
Good evening, Anna. Good evening.
Good evening, Andy. Sir, Raghuprasad Sir is also coming. Today we are presenting him.
Namaste,
Hey,
sir.
Vicky, ma'am.
Namaste.
Namaste, ma. Thank you, ma. Coming, ma, in 2 minutes. We are in front of Rajbhavan. Coming.
Okay, sir. Okay.
Kondala
చక్రధర్
garu, good
గారు
evening.
బాగున్నారా?
Bhavan, how are you?
Sir.
Thank you for the remembrance. Thank you.
Good evening, sir.
అందరికి నమస్కారం.
Good evening,
Namaste,
Chakradhar garu. Good evening.
Good evening,
Good
ma'am.
evening, madam.
So, how is the connectivity?
ఓపెన్ చేయాలి.
I think it's works good, ma'am.
చెప్పండి రత్నం.
As my audio.
Here there is some power problem.
Yeah, little bit problem, but Chakra Sahib is on the way. No problem.
Oh.
Afternoon we tried.
Okay, sir. Okay.
In the afternoon we tried more than half an hour. It is so good. I think in few minutes, power problem is there. With few minutes, sir. Kindly excuse.
Okay, sir. Okay.
మధ్యలో కరెంట్ పోయిందా?
Meanwhile, Kondala garu.
గుడ్ ఈవినింగ్ అండి.
Good evening, Kondala garu.
బాగున్నారా?
Kondala sir ku namaskaralu. Great
నమస్కారం
man.
అండి. నమస్కారం.
కొండల గారు
ఆ,
ఒక 4 నిమిషాల టైం ఉంది, మీరు ఒక పాట పాడకూడదు?
అలాగే
ఒక పాట
అందరికి ఓకే అంటే నేను పాడతాను.
Okay, sir. Please.
పాడండి ఒకటి.
Okay, sir.
అందరికి అందరూ దయచేసి వినండి. కొండలరావు గారు
Okay.
మంచి గాయకుడు అని నాకు మొన్ననే తెలిసింది. బట్ చాలా బాగా పాడతారు ఆయన అన్ని పాటలు కూడా. ఒక 4 నిమిషాలు
స్వాగతం.
ఉంది కాబట్టి మనం వారిని ఒక పాట పాడాల్సి కోరుతున్నాను. ఇలా చైర్మన్ గారు వచ్చే లోపు అందరం వింటాం సరదాగా.
ప్రకృతి ప్రేమికులు గాయకులు.
నదీ సుందరి సుధాస్యందిని నగాధీశ్వర నందిని నడచికోన నడుమకాన కడచి వచ్చిన నవచరి నదీ సుందరి. ఇది యాక్చువల్ గా మన దేవులపల్లి వెంకటకృష్ణ శాస్త్రి గారు రాసిన భావగీతం అన్నమాట. నది మీద ఎంత సుందరంగా అది ప్రవహిస్తుంది, అది తిరుగుతుంది, అది సౌండ్ చేస్తుంది, శబ్దం చేస్తుంది అనే దాని విషయంలో. అందెలా కడియాల గలగల అందమౌ చిరునవ్వు కలకల మందముగనిట తొందరగనట మలుపు మధుర భంగిమ నదీ సుందరి సుధాస్యందిని నగాధీశ్వర నందిని. కరులు నీపై ఒరిగిన చిరురెమ్మతో ప్రతి కొమ్మతో కరులు నీపై ఒరిగిన చిరురెమ్మతో ప్రతి కొమ్మతో దరిని దాగుడు మూతల సయ్యాటల మరి పాటల దరిని దాగుడు మూతల సయ్యాటల మరి పాటల నదీ సుందరి సుధాస్యందిని నగాధీశ్వర నందిని నడచికోన నడుమకాన కడచి వచ్చిన నవచరి నదీ సుందరి. థ్యాంక్స్ అండి.
థ్యాంక్ యూ సార్ కొండలరావు గారు. ఇవాళ
Thanks,
మనము ఇన్స్టిట్యూట్ ఆఫ్ ఇంజనీర్స్ అంటే మనం చైర్మన్ గారు రాగానే దీన్ని ప్రారంభిస్తాము. ఈరోజు మన ప్రొఫెసర్ కె గోపిచంద్ 4వ ఎండోమెంట్ లెక్చర్, 4th ఎండోమెంట్ లెక్చర్ ఈరోజు మనం జరుపుకుంటున్నాము. ఈ ఎండోమెంట్ లెక్చర్కు ముందుగా ధన్యవాదాలు. మన కొండలరావు గారికి ధన్యవాదాలు. అడగగానే ఒక మంచి పాట పాడించి మన కొండలరావు గారికి ధన్యవాదాలు తెలుపుతున్నాను నా తరఫున, ఐఐటిఐ తరఫున కూడా. ఈరోజు ఇక్కడ మనకు ఇంజనీరింగ్ ఎన్వి చక్రధర్ గారు వారు రావడం చాలా సంతోషం. ఇట్ ఈస్ అన్ ఆనర్ టు ద ఇన్స్టిట్యూట్ ఆల్సో. వారు సీనియర్ సెక్షనల్ ఇంజనీరు బ్రిడ్జెస్ ఇండియన్ రైల్వేస్. సో వారు ఈ రోజున మనకి ఇండియాలో మనకు తెలిసి ఒక పెద్ద సంచలనం, అతిపెద్ద సంచలనమైనటువంటి ఏ మోడర్న్ ఇండియన్ ఇంజనీరింగ్ మార్వల్, ఇట్ ఈస్ పంబన్ వర్టికల్ లిఫ్ట్ బ్రిడ్జ్ అన్నది మనం మిగతా అగ్రరాజ్యాలతో కూడా అగ్ర దేశాలతో కూడా పోటీపడి చేసినటువంటి పెద్ద ఇంజనీరింగ్ మార్వల్ అది. సో దాని మీద లెక్చర్ ఉంది. ఇంకా కొద్ది క్షణాల్లో చైర్మన్ గారు విచ్చేసిన తర్వాత ఈ కార్యక్రమం ప్రారంభం జరిగించడం జరుగుతుంది. కైండ్లీ బేర్ విత్ us ఫర్ కపుల్ ఆఫ్ మినిట్స్ ప్లీజ్, ఆల్ ఆఫ్ యూ. ఈ లోపల ఐఎస్ఎన్ రాజు గారిని 2 మాటలు మాట్లాడేది కోరుతున్నాను. రాజు గారు.
Sir, we are joining, sir.
సార్ గుడ్ ఈవినింగ్ సార్.
అవును సార్.
అందరికి సాయంత్రం శుభాకాంక్షలు. ఈ రోజు మనం ప్రొఫెసర్ గోపిచంద్ గారి 4వ ఎండోమెంట్ లెక్చర్ మనం ఈ రోజు ఆర్గనైజ్ చేసుకుంటా ఉన్నాం. ఈ ఎండోమెంట్ లెక్చర్ ని మన పద్మజ సుధాకర్ గారి దంపతులు ఇది యాక్చువల్ గా వాళ్ళు స్పాన్సర్ చేయటం, దీన్ని కూడా ఎస్టాబ్లిష్ చేయటం జరిగింది. ఇది ఇది 4వ ఎండోమెంట్ లెక్చర్. గత 3 ఎండోమెంట్ లెక్చర్స్ కూడా ఆయనకి గౌరవనీయులు గోపిచంద్ గారికి ఎంతో ఇష్టమైన ఈ రైల్వే సంబంధించిన సాంకేతిక అంశాల మీదనే మనకి జరుగుతా ఉన్నది. ఈ రోజు మనకి ఈ పమ్మన్ బ్రిడ్జ్ అన్నది కూడా దట్ ఈస్ వన్ ఆఫ్ ది మార్వెల్ ప్రాజెక్ట్. అంతకుముందు కూడా ఓల్డ్ పమ్మన్ బ్రిడ్జ్ కూడా మనకి మెట్రో శ్రీధరన్ గారు బాగా ఫేమస్ కదా. ఆయన యాక్చువల్ గా ఒకప్పుడు దాన్ని రిహాబిలిటేషన్ చాలా షార్ట్ టైంలోనే తక్కువ కాస్ట్ తో చేసి ఆయన ఎంతో ప్రఖ్యాత గాంచారు. ఇప్పుడు దానికి లైఫ్ సైకిల్ అయిపోవటం వలన కొత్త బ్రిడ్జిని మనం రైల్వే బోర్డు దాన్ని నిర్మించి ఈ మధ్యనే కమిషన్ చేయడం జరిగింది. ఈ రోజు ఈ ఎండోమెంట్ లెక్చర్ లోని దాని టెక్నికల్ ఫీచర్స్, అదే విధంగా బ్రిడ్జ్ కన్స్ట్రక్షన్ లో ఉన్న ఇష్యూస్, టెక్నికల్ ఇష్యూస్ కానీ ప్రాబ్లమ్స్, అంటే ఈ బ్రిడ్జికి మిగిలిన బ్రిడ్జ్ లా కాకుండా ఆల్మోస్ట్ సీలోంచి వెళ్ళిన బ్రిడ్జ్ ఇది. అది దానికి మనకి టైం మనకి యాక్చువల్ గా వర్కింగ్ టైం కానీ వర్కింగ్ స్పాన్ కూడా తక్కువ ఉంటుంది. సో అయినా కూడా ఆన్ టైం కంప్లీట్ చేయడం జరిగింది. సో అటువంటి మంచి కార్యక్రమాన్ని ఈ రోజు ఎండోమెంట్ లెక్చర్ గా మనం ఏర్పాటు చేయటం ఎంతో ముదావహం. తర్వాత మన గోపిచంద్ర గారు కూడా మొట్టమొదట ఆయన వెంకటేశ్వర యూనివర్సిటీలోని ప్రొఫెసర్ గా పనిచేశారు. తర్వాత జేవిఆర్ కాలేజ్ గుంటూరులో కూడా ప్రొఫెసర్ గారిని పనిచేసి ఎంతో ఎంతో ఇంట్రెస్ట్, అదే విధంగా టెక్నికల్ ఇష్యూస్ లో కూడా చాలా మంచి పేరు ప్రఖ్యాతులు సంపాదించారు. అటువంటి వారి పేరు మీద ఎండోమెంట్ లెక్చర్ రావటం, ప్రతి సంవత్సరం కూడా ఆయన పుట్టినరోజున మనం ఒక టెక్నికల్ ఈవెంట్ ఆర్గనైజ్ చేసుకుంటా ఉన్నాం. ఆ ఈవెంట్ లో కూడా దేశంలో ప్రఖ్యాతిగాంచిన ఇంజనీర్ల యొక్క ఈవెంట్స్ నే వారు స్పీకర్స్ గా పెట్టడం జరిగింది. సో ఆ విధంగా 4వ ఎండోమెంట్ లెక్చర్ లో కూడా చక్రపాణి గారు, వారు యాక్చువల్ గా మనకి చెన్నైలో ఉంటారు. వారు ఈ ప్రాజెక్ట్ లో పూర్తిగా ఇన్వాల్వ్ అయ్యారు. సో వారు స్వయంగా ఈ ప్రాజెక్ట్ సంబంధించిన ఎగ్జిక్యూషన్ డీటెయిల్స్ చెప్పడం మన అందరికి ఎంతో మంచి అవకాశం దొరికింది. మా చైర్మన్ గారు ఒక కొద్ది నిమిషాల్లో ఇక్కడికి వస్తారు. ఆల్రెడీ రీచ్ అయ్యారు. 2 నిమిషాల్లో ముందు చక్రపాణి గారు మన గోపిచంద్ గారి పటానికి పూలమాల వేసి వాళ్ళకి నివాళులు అర్పించిన తర్వాత మన టెక్నికల్ ప్రోగ్రామ్ సాల్వ్ అవుతుంది. అది ఒక 2 నిమిషాల్లో మన కార్యక్రమం సాల్వ్ అవుతుందని చెప్పి ఈ అవకాశం ఇచ్చిన నాకు చైర్మన్ గారికి, సెక్రటరీ గారికి ధన్యవాదాలు తెలియజేస్తా ఉన్నాం.
I solved them, huh? Thank you. What?
చైర్మన్ గారు వచ్చేసారా? చైర్మన్ గారు సార్, షల్ వి స్టార్ట్ సార్? చైర్మన్ గారు
అందరికి సాయంకాలం నమస్కారం సార్. మీ హెల్త్ సెక్రటరీ కైండ్లీ స్పీక్.
థ్యాంక్ యూ. సో సార్, చైర్మన్ గారు స్టార్టింగ్.
Yeah. Now we going for
మరొకసారి ఈ కార్యక్రమానికి ప్రొఫెసర్ కె గోపిచంద్ 4th ఎండోమెంట్ లెక్చర్ గారు ఈ కార్యక్రమానికి విచ్చేసినటువంటి అందరూ ఇంజనీర్లందరికీ స్వాగతం పలుకుతూ నేను ఫ్లోర్ ని ఐఎమ్ హ్యాండింగ్ ఓవర్ టు ద చైర్మన్ ఫర్ ఫర్దర్ ప్రొసీడింగ్స్ టు కంటిన్యూ.
let's go for lighting kindly.
అంటే చాలా
ఒకటే కూడా పెట్టిన టెస్టింగ్ సార్ సార్ जोहार क्वेश्चन गुप्त विद्यार्थी मैडम मुझे किसी को मुझे बिठा यस सर both of you sir then I said sir both of you then Anna yes here no it is आइए सर राजा रेडी मैं तो आइए सर हनु खुद ही बैठा नो सर वो कर हां मैं सर खुद सर आओ या राजा ఎన్ని రోజులు రాదు
ఒక గ్రూప్ కూడా
ओके ओके ग्रैंड पास बराबर बेटा मैडम
मैडम कुछ किशोर भाई आगे
अंदर आ Land House Secretary should be. The file put it in. Thank you, sir. Thank you, Hannah Secretary. Special thanks to Madam Padmaji Garu, Sujagar sir, our fellow senior members. Every year, Madam Padmaji Garu, Madam Sir, Parimal Guchidi, both of you. And today's Professor Gopichand 4th Endowment lecture on Pamban Vertical Lift Bridge, a modern Indian engineering marvel. Today, Thursday, 12th February, 6:30 p.m. Sorry, delayed by 5-10 minutes. welcome and today keynote speaker, endowment lecturer by C. Engineer N.V. Chakradhar, Senior Section Engineering Bridges, Indian Railways, Pamba, Chennai, and my friend Mr. Engineer Mari Ramesh, FIE HANA Secretary, our today's cabinet Satish Kumar, my past chairmen Brahmanadi Garu, Aysan Raju Garu, and retired ENC Karin Saab, FIE, our joint HANA secretaries both Sri Mohammad Mohidin Saab, Senior Professor, and my friend recently Dr. Nirama, who got doctorate, and my friend Sajnaz Garu, all SSC Garu, Andarki, Sayankal Namaskal Tiripachukuntu. The galaxy of eminent personalities, past presidents and past chairmen, council members, committee members of IATSC, corporate members, are family members of the late Professor K. Gopichand, Padma Madam and Sir, and media friends, ladies and gentlemen, good evening all, good evening all to those who are online in Zoom. It gives me immense pleasure to extend my heartily welcome to all of you to the Professor K. Gopichand 4th Endowment Lecture on a very important, vital and interesting topic on a Pamban vertical lift bridge, a modern Indian engineering marvel to be delivered by our great engineer N.V. Chakradhar. We are very fortunate to have a stalwarts of eminent personalities, engineer N.V. Chakradhar, and we thank him for sparking their valuable time to be administering this important event. I am glad to inform that Telangana State Center of the Institute of Engineers India has been regularly organizing 22 endowment lectures every year on the birthday of honor of our eminent engineers like Engineer V. Subbarao Endowment Lecture, Engineer M. Tirupati Reddy Lecture, Engineering Professor K. Gopichand FIE Endowment Lecture, Dr. J. Purushottam, G. Prabhakar, Kola Krishna Mohan Rao Garu, B. Anantaramuలు Saab, S. Balakrishna Reddy, G. V. Subbarao, T. Hanumantarao Garu Endowment Lecture, A. P. Ranganath Swami, S. Raghavachari Endowment Lecture, Dr. Nala Tatarao Garu, Engineer Maturi Gopalrao Garu, Gurram Kotiri Garu, Atturi Venkateswara Garu, Engineer R.L. Raju Endowment Lecture, Dr. Jan A. Murray Endowment Lecture, Dr. N.V.L.N. Rao Endowment Lecture, Engineers L. Venkata Krishna Iyer, K.V. Srinivasa Rao, M.L. Swami Endowment Lecture, Dr. A. Ramakrishna Endowment Lecture, and Engineer I. Basavaraj Endowment Lecture. Sir, you told about today Koka Krishna Mohan Rao, sir, Endowment Lecture. Also, sir told in this year we are planning for gold medal. The endowment lectures are being delivered by people of high eminence with a considerable professional experience through lights of the important emerging topics of today's relevance. I say a few words about the Professor K. Gopichand for information of the elite audience. Dr. Kaluru Gopichand was born in Pedagadavalleru, Guntur district on 12th February today, 1934. He did his SSLC from Kongan High School. Did a BSc Honors from Mathematics from Andhra University, DISC in Electrical Technology from Indian Institute of Science, Bangalore, MTech in Electrical Engineering, Electrical Machine Design from IIT Kharagpur, and a PhD in Electrical Transaction from Moscow Railway Engineering Institute. He worked as an assistant lecturer and assistant professor in Electrical Engineering Department at IIT Kharagpur. As a professor and head of Department of Electrical and Electronics Engineering, vice principal and principal of Sri Venkateswara University College of Engineering, Tirupati. He served as a principal and RUR and Jacob College of Engineering and professor and head of Department of the Electrical Engineering Department of Professor. Gopichand was instrumental in introducing the MTech and PhD programs in the development of the Electronics and Communication Engineering Department in SV University, Tirupati. Earlier, he had served as a pilot officer in NCC Air Wing at Kharagpur. His sports interest including the volleyball and badminton careers. Dr. Gopichand was a lifelong learner and teacher of at least latest technologies in electrical telecommunications, computer science and engineering, like microprocessors and computers. Computer programming language, example Java, C++, telecommunications and networking technology, example Wi-Fi. He believed the economic development of a post-independent nation through the technology development and provide the consultation services to the thermal and hydraulic power generation organizations. He conducted numerous conferences and seminars in new technology to encourage their adoption in various industries. He authored several books and technical papers. His academic advisor said his capacity of the assimilation of the new principles increases the mind, giving up the impression that he is a man of the highest caliber. His passion is education and it is the development of future generations is evident of the in thousands of the students he advised guided through the bachelor and master and doctorate degrees. Dr. Gopichand has received many awards during his illustrious career, and most notable among them are Meritorious Teachers Award from Andhra Pradesh Government, Mokshagunda Vishwasariya Award from the Institute of Engineers India, and Golden Lifetime Achievement Award by the Industrial Technology Foundation, Delhi. Dr. Gopichand passed a peaceful and 12 February 2017 in the presence of his family. He is served as by his wife 60 years, Akkama, 2 daughters, a son, 3 grandchildren, among 2 sisters. 2 daughters lo mana Padmaja akka మన దగ్గరే ఉన్నారు. And our fellow member, we are very happy, ma'am. And his younger daughter, Kalyani, is a fellow of Virgin Communications. His son is Venkateshwar, is an engineer, and actually his eldest son-in-law, Poturi Sudhakar Saab, is a former chairman and managing director of ECL, Hyderabad. His younger son-in-law, Bogini Chinchu Ramanayudu, is a president of CEO in Bogini Corporation and Computer Solutions, providing USA. His daughter-in-law, Vijay Bhanu, is an internist in geriatrician. The endowment lecturer proposed a request of Srimati P. Padmaja, FI, retired Chief Engineer Panchayat Raj, and daughter on late Dr. G. Gopichand Garu. The State Center Committee to organizing every year on his birthday since last 2023. Since you are anxiously awaiting to talk from our eminent engineer speaker, I am limiting myself and hope that you will be really enjoying this toss. Latestly, on behalf of the Telangana State Center and Institute of Engineers, on my own behalf, I once again extend a heartfelt welcome all of you to this important event. Thank you, and all. So now I am requesting Kanjara Sanskumar Garu, please introduce our chief guest, the great eminent engineer, Dr. N.V. Chakra, sir.
Thank you, sir. Good evening, everyone. I am very fortunate to introduce Shri Venkata Chakradhar N. Garu, Senior Section Engineer Bridges, Indian Railways. He has a dedicated and experienced civil engineer servicing as a section engineer bridges in Indian Railways, currently leading a team of 18 staff members and responsible for historic old Pamban Railway Bridge and India's first vertical lift railway sea bridge. Known for leadership, he is known for leadership, technical expertise, and a strong commitment to public safety under challenging marine and weather conditions. He has done his BTech in civil engineering from Sri Venkateshwara University College of Engineering and intermediate from Sri Chaitanya Junior College. And coming for professional experience, he is a senior section engineer for bridges, Southern Railways from 2023 to present, and leading 18 members technical team. He is responsible for old Pamban Bridge and new vertical lift sea bridge, ensuring coordination between railways and maritime operations. And also he was junior engineer civil bridges Southern Railways Chennai from 2022-2023 and top 10 RRB rank holder, experience in construction, rehabilitation and emergency restoration of works. His key responsibilities held are bridge inspection, safety audits and corrosion control, emergency response during cyclones, floods and high winds, welding, fabrication, painting and structural strengthening, manual and automated bridge lifting operations, wind speed safety enforcement above 58 kilometers per hour, and coordination with RVNL and maritime authorities. And his achievements are he was promoted to in charge section engineer within 3 years. Interested in India's most iconic railway bridge, key contributions in post-disaster railway restorations, and personality commitment stationed over 1,500 kilometers from hometown, consistently prioritizing duty over personal commitments, recognized for dedication and public service mindset. Thank you, sir. I welcome you to deliver an expert talk. Today, almost many faculty members, research scholars, and eminent engineers were present in this today's section. welcome you, sir. Thank you. Thank you very much, sir.
Yes, sir.
Unmute can, yeah. Thank you, sir.
Yes, sir. Good evening, everyone, and good evening, all respected engineers here. It's very privileged to be a part of here. And first of all, I want to start this day with the blessing of our sir Gopichand Garu. Maybe he's blessing from heaven this day, and I'm thanking Mr. Ramana Naik sir, uh, and Chairman Garu, and Satish sir, and Ramesh sir, and Padmaja madam, who constantly contact with me, and Venkatratnam sir. Because of all these people, I'm here today, and it's a very privilege to be part of here. And first of all, introducing myself, Venkata Chakrathar, senior section engineer. I'm in charge of both railway, old bridge and new bridge. And right now I'm working with a team of 18 people, who responsible for lifting and lowering of both the bridges as of now. And today I want to start. Uh, I want to start because it is a new permanent bridge. It is a 705 crores of project. Okay, it's a huge one. I within what the time limit what I given, so I'll try to give my best. Okay, if you want more, please, I will get in contact with you and I will explain more in detail further. And I'm going to start now. Just I'm sharing the screen, sir. Please tell if it is visible. Sir, is it visible? Sir, is it visible? Screen is visible?
Yes, sir, it is visible.
Okay, thank you, sir.
Full screen mode lo పెట్టు.
దాన్ని డబుల్ క్లిక్ చేస్తే ఫుల్ క్లిక్స్.
So, first of all, I want to start with today's lecture with Old Palmer Bridge. I can tell it's a timeless marvel. You can see the Old Palmer Bridge, which is opened while moving the ship. It was constructed in 1914. It took around 14 years to complete, and it came to the picture in 1914 and it served up to 2022. I think it served more than 108 years, and now it's going to start now dismantling. And where the Palmer Bridge is there, okay, you can see the location map here. Here it is India's mainland, and here the round circle where the portion is there where the Palmer Bridge is located, and here Rameshwaram Island is there. So Palmer Bridge is the location where connecting India's mainland with holy land of Rameshwaram. Actually, why these bridges came into the picture? Why? Because previously Britishers want to do trade with Sri Lanka. Okay, to do a trade with Sri Lanka, they want to ship their things. For that, they thought that to shift their materials up to Rameshwaram to Dhanushkoti here, so they can easily carry, because 18 kilometers from there, the Talaimanar, the area of Sri Lanka. So that's why they constructed the bridge, the thought, and they constructed, and it came into the picture from 1914. Okay, it's the satellite view from the top, and this is Sri Lanka. This is India's mainland. This is the portion where our Palmer Bridge will come, and this is called Ram Setu, what you can see. And actually, the Rameshwaram Island is a part of mainland only, India's mainland, but is when 1914 and 80, okay, due to heavy cyclone, that time that Pamban or Rameshwaram Island got separated from mainland. Many researchers are telling also during the 1480 only that Ram Setu bridge also got destroyed so much, and it took more than 2,000 tons of steel, 2,000 people which worked for around 14 years. Okay, and they completed in 1914 February 24th. And parallel to that, okay, another bridge is there, that is Rodova Bridge, which was opened in 1988 by PM Rajiv Gandhi. Okay, you can see that few pictures of old Palm Bridge, which was opened in 1940. Britishers were proud walk after the completion of the thing, and this is few pictures of that. And this is the where that Dhanushkoti area. I told right that the train will come up to Dhanushkoti, and there they move that up to inside the ship, and ship will pass to Talaimanar. And everything is good, 1914. But 1964, a heavy cyclone hit that entire Rameshwaram island. During that cyclone, actually the bridge is totally, old bridge is totally 145 spans. In that 145 spans, 124 spans are washed. You can see at the below, he is Mr. Metro Man of India. Okay, he is Sridharan Garu. Okay, at that point of time, he is Senatian North here in Madurai. Okay, within 60 days, he restored the track again, which shows that engineering, okay, resilience within, because that spans are washed away 2 kilometers, 3 kilometers, and the people pulled back with the cranes. People helped themselves within 60 days and restored the track. You can see the track how it happened, because that time wind speed went to 240 kilometers per hour. You can understand how much big it is. More than 2,000 people have died in the island, and more than 200 people are died at the time accident has happened. During train accident happened, and more than 200 people, near 200 people are died. You can see Metro Man of India, E. Sridharan Garu. I tried to contact sir. Actually, sir is still there in, I think, in Kerala. I hope, actually recently I tried to contact sir also, so sir can come and see old bridge before its dismantling, and new bridge want to see, because he did so much to this bridge. And you can see that road over bridge, which is called as Indira Gandhi Bridge, which is started construction 1974 and completed 1988. It took 14 years to complete the thing, and which is 2.34 kilometers high. This is the picture. You can see road over bridge and old Palm Bridge. And then new Palm Bridge, why it came? Okay, because old bridge is 914, it ends out to 2022. It's out more than 108 years. But for the modern train condition, load conditions, okay, modern technology and modern speed conditions, okay, but old bridge is not withstanding it. That's why it's not new bridge is not just a replacement. It is like a revolution of the modern things. You can see the Modi ji came on November 2019 and laid the stone with a project cost of 250 crores initially, with 2.05 kilometers. And why new Palm Bridge came? Because that you can see that lifting span you see, right, two bases open like this, and it is severely corroded, because it was generally it is taken from London at the point of time. It took 2 years to fabricate it there and in London, and on the ships they're taken to here and they laid here. So it over the time, 200 years, it's got corroded. So it's severely corroded. That's why we want to change. And speed of over the bridge is 10 kilometers per hour. For the modern conditions of speed conditions is very less. Okay, and because of this thing, IIT Madras came into the picture and they installed stress and strain gauges. After train movement, at one point of time, the stress and strain gauges become red danger, and the train services stopped in the December 2022. You can see left side new Palm Bridge. Year of sanction is February 2019, and foundation stone in November 2019, and commission in 2025. And construction is less than 5 years. In these 2 years are impacted. You can see Indira Gandhi Road Bridge, which took 14 years. You can understand how much faster in the sea of 2 kilometers bridge is constructed within less than 5 years. In that 2 years are Corona. You can understand. So how much engineers are did this work day and night. You can see the picture This is the existing road and existing old permanent bridge. Parallel to that, new permanent bridge came, which is called vertical lift span, which is the heart of the bridge. One side is the Pamban, other side is the Mandapam. Pamban is the Rameshwaram side, and Mandapam is the India's mainland side. What are silent features of the bridge? Bridge length is 2.08 kilometers, and there are totally 100 spans are there. In the 99 spans are 18.3 meter girder, and one span is our lifting span girder, which is 72.5 meter length. Basically, that every pier having 3 pile group. Each pile is 1.5 meter dia, 3 pile group. Whereas lifting lift span area is there. There 15 pile group is there. 3 into 5, 15 pile groups are there, and they're totally. I can say that how much height it will lift. It totally lifts 17 meter height, already having 5 meters clearance from the high flood level to the bottom of the girder. So totally we have a drift of 22 meter. When the vertical lift span lifted, we can able to see 22 meters of height difference for movement of the ships, and it will lift up to the road level. So here the two major problems are there in this location of the permanent bridge. One is corrosion, and second is wind velocity. Corrosion is the main prevailing thing here. I came to know that after Miami Beach, this is the second highest world corrosion area. In the world, this is the second highest world corrosion area. I can understand how much corrosion is there here. Okay, that's why because of that, we taken the precautions are what like that. Entirely, the lift span is totally welded girder, no bolted, no riveted. It is totally welded connection, and we use a special protection scheme, zinc metallizing of 200 microns, above that epoxy sealant of 25 microns, above that polysiloxane of 125 microns, total 350 microns as a protective layer, as a painting scheme here. And rail level also raised 3 meters from old bridge to new bridge. Why 3 meters lifted the rail level? Because the problem is the waves below the bridge is splashing, continuous splashing of water is happening on the girder. When the continuous splashing of water on the girder, that because there's salt water, continuous wetting and drying happening on the surface of the bridge. Because of that, the corrosion becoming more. That's why we raised 3 meters more the rail level. So the splashing of water, we can avoid it. So obviously we can reduce the corrosion over the time. And second one, I told one is corrosion, and second thing wind velocity. That's why I told that 250 kilometers per hour wind velocities happened when 964. Okay, that's why we placed anemometer at pier number 38. Why? Because this anemometer is connected with the signals. So the signals, there is no signal on the bridge. Signals are there on approach side, outer side, on the land only the signals are there. So when wind velocity, this is continuously monitoring, that anemometer continuously monitoring the wind velocity. When the wind velocity is more than 58 kmph wind velocity, automatically the signals become red. So the train movement will be stopped on the bridge. So until that, when wind velocity comes below the 58 kmph, then there's no movement of the trains on the bridge. You came to know that you might listen somewhere, sometime the train cancel to the Rameshwaram and stopped at Mandapam. Why? Because the wind velocity is more. During cyclones, we used to face this type of problem. And there's what is the planning here? Okay, and I think all the engineers may know. Okay, fabrication should not be done near the sea. Okay, it should be more than 30 kilometers away from the shore. That's why we found Satrakudi as a station where it is a coastal region. It is more than 30 kmph from the seashore, and there the fabrication unit, everything is placed. And design basis, these are basic things. Seismic zone 2, and the grade of concrete we use as the M34, and steel as 430, 410, and the pile foundation, yes, I told that 3 pile group, which is a 1.5 meter dia piles. 6 pile group as abutments, and 15 pile group where lift span is there. And where the design basis. This is before I talked about substructure. When I'm coming to superstructure, there are, I told, total 100 spans are there. There are 99 spans of 18.3 meter girder. As per the RDS4 design, 18.3 meter girder as a girder we placed, where the height of the bridge is 72.5 meter, which is a lift span. Things. And we have two curvatures at both the ends of the bridges, because we have to connect existing rail. Existing rail is very straight, but our new bridge, we have to connect new railway line. I have to connect with the existing rail. That's why the curvature is there at the both the ends. At the A1 side, we are having 0.35 degree curvature, and the A2 side we are having 2.65 degree curvature. And we having lift span. There we used E350 grade steel for the tower, struct, and machinery room. And the pile foundation, as I told, we adopted three methods. Land mode method, which is for one land mode method means from land only, from one span number 1 to 9. Okay, up to pier number 9, we did land mode method. After that, pile rig mounted method up to 77, and 77 to 100 we used gantry method. And fabrication of approach spans, I told 18.3 meter girder, which is the total span is 19.65 meter, which is fabricated at Satrakudi, and which is taken to the site. And the fabrication of lift span is happened. It is 72.5 meter girder, which is, we cannot shift that 72.5 meter girder directly from more than 30 kilometers. It is not possible. That's why we made into primary and secondary members, and that we shifted to that A to N approach. We assembled there and we moved by the launching girder. I will show in the video how it has happened. You understand more in that video. And fabrication of towers, tower lintel. I will tell what is the tower. You can see here, this is called towers, which is the vertical one. You are seeing the towers. Top is the machinery room. I think who are joined the mobile, all the participants may turn hot landscape mode. You can understand it better than vertical. Coming back, this is the towers. You're seeing that two towers, tower A and tower B, where the top is the machinery room, and the box you are seeing, right? This is counterweight. Okay. And this is the wide ropes. So the tower, you can see that two shaft. The tower of size is 3 into 2.3, and the clear between 15.3 meter, and it will lift up to 17 meter height. I can say that the bridge will be lifting up to 17 meter height, which is equal to the road over level. Up to road over level, it will lift. And total weight of the tower is 300 metric ton. That counterweight is the major part here, 312 metric ton. You are seeing that this box is right. This is called counterweight, which is 310 metric ton. One side, other side is 310 metric ton. Our bridge weight is 660 metric ton. So bridge weight is 660, 310, 310. 310 plus 310 is how much? 620. Bridge weight is 660. The difference is 40 ton only. The 40 ton difference only we are using motor for lifting the bridge. So here 95% of carrying capacity, lifting carrying capacity of the bridge is taken care by this counterweight. That rectangular box you are seeing, right? This is called counterweight, which is stable with the 6 wide ropes at each corner is there. So only 5% of load carrying capacity we are using motor to rotate. This is how we did. We are using SCADA for operations. You can see here, there is a machinery room on the top. This is a counterweight, and we are having sheave like a pulley. I can say a small one. One side, this is the top is pulley. One side is having counterweight. Other side we are having our bridge lift span. So when that bridge will lifted, counterweight will come down. That's how it is. You will understand more better in the video. So we are using SCADA technology because for old bridge we are using manually. At each corner we are using 4 to 5 people. We are standing at each corner. Totally we require 4 into 4. 16 people is required to rotate the bridge, and the old bridge will open up to 81 degrees. So it took us 40 to 50 minutes to open 25 degrees of thing. But a new bridge we are opening within 6 minutes of 18 minutes. So for old bridge we took 40 minutes. For new bridge we are opening within 6 minutes. It's because of we are using the new technology, electromechanical mechanism you are using. That's why we are lifting the bridge within the short time. It's in a safety manner. And the SCADA, what is SCADA is just nothing like, but it is operation. It is connected to all the things, sensors, everything. One person can good enough for operation for lifting of the bridge. At what rate? 326 seconds, which is equal to the 6 minutes. We can lift the bridge. So what we can monitor is continually we can in SCADA we can see that everything, what is the wind velocity is there, everything, all parameters are within the limit or not, the wire ropes are there. Okay, there are so many parameters are within the limit or not. It is SCADA will check if anyone thing which is not in the limit, so then we cannot able to lift the bridge. So we'll correct it, then we can continue the further. So if anything problem is there, we can able to see in the SCADA. And what is the innovation applied here in the new bridge? It is we adopted a higher dia of the pile, 1.5 meter dia, to reduce the number of piles. There are 3 pile group. Only we are using 1.5 meter dia, and we used admixtures here for reducing the water and corrosion, because it is a seashore area. And the lift span is fully welded girder. There is no bolted anything for for not have good resistance towards the corrosion. And our we adopted 20 meter rails we can easily place, and 19.65 meter of length we can easily transport from the Satrapudi of, I told right, to shift the place. 20 meter of length of girders. And what are the challenges faced here in the permanent new bridge? Pandemic. Within starting of 4 months, the pandemic attended, corona, which is severely affected because we have to work 500, 600 people every day. So that time, if corona is there, how we can survive? How can we continue the work? So it's severely affected. In that also people are there, we work, and within completed 50, less than 5 years, before I told it. And as access to work site, it is very difficult to move the things, because work site is very difficult, because only one route is there through the very narrow road. If anyone comes, you might know how much difficult here. And the transportation is done 20 meters from Satrapudi, more than 30 kilometers to here. And sea is very rough. Here it is sea. Due to the sometimes high tides will become, low tides will come. If we can, the depth of water is not like so much, 2 meter, 5 meter, 6 meter. Only in navigation channel only we are having 4 to 7 meter. Other spans we are having only less than 1 meter. If less than 1 meter is there, so shifting of materials is very much difficult, because our weight is more than 100 metric ton, 150 metric ton, 200 metric ton, because we have to shift that things. So that time we have to shift in only high tide times. High tide time we have to wait, whether it come in the evening, morning, we don't know. And we have to work in the heights. And the launching of lift span, because we have to shift the lift span from ear to end to center of the bridge. I told right, we're having curvature at both the ends. Okay, so moving that 525 metric ton, that time on the top there is no railway track is there. If railway track, the sleepers, everything is there, then that weight is 660 metric ton. Before, if we remove that top load, 525 metric ton, to shift that ear to end to center, that is location, we have to move in the curvature of 2.65 degree curvature. We have to move. To understand more in that video, we'll show it. We use spherical bearings for the lift span. Other bearings are normal bearings. For the lift span, we are using spherical bearings. And this you can see, you can understand more from the pictures now. It is Mandapam side, India's mainland side, the loading jetty. From here, the piers. I told it from land method we used from 1 to 9. 1, 2, 3, 4, 5, 6. Land method. From the land only we install that piles. Initial pile load test is done and dynamic load test is done. And dredging of sea is facilitated to move the bridges because I told it that depth of water is very less here. So that's why dredging is done manually to facilitate the movement of our barges or pontoons from one end to other end. And the liners we used deep lorry. And for other spans after 9, we used pile rig mounted jack barges for making that our piles. And floating batches planned for concreting purpose. After placing that liners inside, we have to fill it with concrete, right, for that. And we used to transport our transit mixtures on the pontoons with the using of ships, the pontoon shifting to that specific location to unload that our concrete. And the reinforcement bars are cleaning before water with water jet because already it's a corrosion provision area. Okay, that's why before making the concrete, it's with the high air water jet. Okay, we clean that surface of that reinforcement. And the reinforcement of where the lift span is there, you can see the reinforcement, everything. And it is we covered with the roofing because because 855 cubic meter of concreting is not done within 1 hour or 2 hours. It took more than 24 hours. So that's why a clear hut is there. So not to have any rain or something to be done. And this is a complete view of the substructure. You can see the 3 pile group at the bottom. This is a pile crab and pier in the top combinedly. And on that top, we applied epoxy painting for safety purpose. And you can see the electrical building at the side or near the vertical lift span. Here, entire electrical portions, we're having generators and we have rooms also. There, here, our bridge operator will be there, continuously monitoring 24/7 for the movement of the ships and the trains. And slope compaction network done on both the ends. You can see the it is new line, right? That's why slope compaction is done. And there's a few photos and some safety campaigns also done because that time corona time you can see that people are wearing mask everywhere. The time is corona time. And I told it's fabrication unit we placed at Satrakudi more than 30 kilometers from the end. This is the area the fabrication unit is done. And you can see approach spans girders. We did flame cutting, CNC machine. And some of the art welding we adopted. For that we did whether that are done properly or not welding, the die penetration test for the approach spans. For every girder, every die penetration test we did. And fabrication of approach spans. Surface preparation is done with grid blasting. About that zinc metallizing is there. About that polysiloxane paint, I told a total 350 microns of paint we did. First zinc metallizing, about that epoxy sealant, about that polysiloxane of 2 ports of 125 microns. Total 350 microns, which is the new painting scheme we adopted for this new Palm bridge. After that, we checked with the DFT, dry film thickness. It is more than 350 or not. And HFC bolts we adopted, so we tested it is more than the limit or not. And assembly, finally inspection, whether it's properly within the limit or not, 19.65 or not, everything, the length, everything is checked. After that girder moved from Satrakudi to the site. This everything what you seen before, it is made at fabrication unit Satrakudi, and then we loaded into the lorry Satrakudi to the site. And here the launching, how we launched the approach spans, you can see it. It is, you can clearly understand. Here we having launching approach span girder. We are launching with using, on the top we are placing, this is launching girder. On that we are moving this. This is a lift span you are seeing. By using the jack crane, we are lifting and we are moving to the specific location, leading to the span to the, it is like A-frame, what you're seeing it, A-frame, and placing on the bearings, pet plate. And how track is limited, you see before there is no track on the, there is no track, only the girder is there. The track and this 20 meter of track plate, it is moving on the top and placed there. So you can see the top view, that A-frame on both the sides and moving. First we place the girder, and after above that we are placing our track plate, everything. And this is for approach girders. Whereas lift span girder, this is totally 72.5 meter. So we cannot move the 72.5 meter of length from that more than 30 kilometers. We cannot move. That's why it made into segments, and we fabricated at the site. CNC machine, we cut into the things, we check welding it, because the lift span is totally welded. There is no bolts are there. So fabrication of lift span is happened at Satrakudi only. Is as primary members, secondary members. That time fabrication of end segments, everything. You can see the different photos. Finally, welds are checked with POT method. See, after finally assembly happened, whether it is properly or not at the Satrakudi. It is not welded. It's just trial assemblies happen at the site of the lift span. Then we properly covered the ends with the cover, because it is a corrosion area, right? So the ends are totally covered with the wrapper covers, then moved to the site. So at A to N towards permanent, we made a platform. Above this, that lift span is got one by one got welded in a closed condition. This is the, you can see view of assembly platform here. This is the assembly of, I told right, we made into primary and secondary members, placed side by side. The bottom cross girders. You see the top view of the assembling of that lift span. Because you can see that green covers, because I told that we cannot do welding at near the seashore. That's why in the closer condition, we did welding of that primary, second. We reduced it up to maximum, so that the number of members should be less. That's why welding huts are made at the site. Complete assemblies happen at the site. After assemblies happen, then painting is done for one layer, and then as that lift span is ready. Then we have, now we have to, the next task is we have to move from A to N to lift span. It is totally more than, I can say that 500 or 600 meters we have to move. So it took more than 5 months, I can say, to move every day 1 meter, 1.5 meter. We moved that lift span. See that by using launching girders, you can see the bottom. You'll understand more. I will show the video how it moved. By using launching girder at the bottom, and above that lift span slowly moved towards our lift span location. And you can see here, well, this is our navigation channel. You can clearly see. There we did 3 supports for moving of the lift span. This is how it moved. And finally, it came to this position. And I still remember that day it came into the position. We lowered that thing. It is, I think it's 12 or 1 night, 1 o'clock. We've cracked the crackers, everything. That's a memorable day for me, because after so much of time, so much of efforts of not only me, it's so much of engineers are behind this thing. So I seen that happiness in everyone's eyes that time. Still I remember that day. And this is the electromechanical equipment. I told that machinery is there on the top of the tower lintel. There, this entire assembly, we trial assemble. So whatever we did, placed it at the bridge, we made trial assembly at the site yard before Satrakudi. We checked, then only we moved to the site. It is easy, right? So you see that tower, we made four components that placed one by one on the top at each side. Erection of tower is happened. And above the tower, this is machinery room. So entire machinery, I told this sheave, this primary, secondary gearbox, everything will come inside this machinery box only. It will come on the top of the tower. Before that also, at A to N, we did trial assembly. So whatever we are making, want to place, we did trial assembly at the site or A to N. If it is everything okay, then only we move into the site. So by using Pantone, we move to its location. This is the bridge you can see left. By using, why are we moving this direction? Because we need depth of water is more. Because Pantone, the weight is so much more. That's why moving in this direction. So after that, erection of lintel is happened, the machinery room on the top of the towers. And after the placing, this is the sheave. I can solve pulley is a smaller one. Sheave is the bigger term. If it is bigger inside, that is called sheave. It's placed on the top. And after placing the sheave on the top of the cover, we did. So finally, it looks like this. That a sheave is there. That this is machinery room. So to operation, we did on the entirely from the top only. So we did load deflection also by static with the different speeds also with 10 kmph, 30 kmph, 50 kmph, 80 kmph. Actually, the bridge is designed for 80 kmph, but now bridge or trains are running for 50 kmph on the bridge right now. Load test also done. Static light load test also done. On the approach guard, this is lift span. You can see the load test is done for reflection test for normal 18.3 meter girders also. So this is a top view. You can see here. The bottom you are seeing, this is the Pamban area. That is India's mainland. This 2-kilometer stretch is, you can see this is road bridge, old Pamban bridge. This is new bridge. This is the top view of the Pamban bridge. And this is another view from the Pamban end. Is a lifting. After lifting, I told that 70 meter it will lift. Total 22 meter it will come. So this below, it's totally 22 meter. This will equal to the road level. You can see the road is there at left side, which is equal to this after lifting. So it will totally, we have 22 meters, 8 lift will be there, which is sufficient enough for the movement of the ships in this path. This is from after action totally from Mandapam end. This is from Pamban end. The photo. This is after view after seating of the bearings, properly seated. Before that, I shown that is a lifting condition for the movement of ships. Now it is a properly seated condition for the movement of the trains. This is another view of the lift span. This is the top view of the lift span. I can say heart of the bridge. This is only the lift span. And April 6th of 2025, Prime Minister Modi ji came and inaugurated that new bridge. And how much beautiful it is there in the morning, night it is so much of beautiful. So it's totally RGB lighting is there in the lift span, which cost of 6 crores, only lightning itself. That is so much of beautiful. You can see that recently for January 26th, we switched on the lights for the new Palm Bridge. This is the bridge. Okay, so I think if anyone comes towards Rameshwaram, please let me know. I will definitely switch on lights for you. Generally, we will not on. Very rarely we will on. So, but I will do. I will show the video right now. After that, after showing that video, I can take the questions, whatever is.
Any problem? Chakrata sir, completed?
No, sir, I'm sharing the video. Yeah. You can see the top India and Sri Lanka. You will zoom in. You zoom in. You can see that where the Palm Bridge is there. This location. See, if any international ships are there, they have to move below the Sri Lanka only. To move the ships from near India means we have to move through outside the Dhanushkoti or near Paman only. You can clearly see it here. So the ships should move in this direction only. So definitely they will move the ships inside Paman only. So that's why we have to lift the bridge or lower the bridge. So many people are requested to move their ships. International ships will cross over the Sri Lanka.
The new Pamban Railway Bridge is proposed to be constructed parallel to old railway bridge connecting Mandapam and Pamban towns. This new bridge is located at a distance.
Sir, voice is coming, sir? Audio is coming of the video?
Audible. Chakrata sir.
Yes, sir. Okay, sir.
No, voice is not coming. Voice is not coming.
Oh, repeat again, sir. Repeat again.
చూడే ఇప్పొస్తుంది వాళ్ళైతే చూడు
Sorry for the delay.
Distance of 50 meters from old.
Is it now audible? Anyone can please confirm?
Bridge and have 99 members.
Is it audible now, sir? Okay. Thank you, sir. Thank you.
Of 18.3 meters length spans and 172.5 meters length lift span for navigation purpose. The total length of bridge across sea is 2.078 kilometers. Ranjit Buildcon Station, 30 kilometers away from seashore. The fabrication yard is located near Sathirakudi railway station, 30 kilometers away from seashore.
ఇది కూడానా నేనైతే నాకు ఇంకేమైనా ఉందా
చక్రధర గారు మీ వాయిస్ వినపట్లేదు, అన్మ్యూట్ అవ్వండి.
Sorry, sir. Sorry for that. I told it more than 30 kilometers from Shirshore. It is more than 30 kilometers, not from the location of that palm fish.
The distance from workshop to assembly location on site is 62 kilometers by road.
Now,
And 18.3 meters span plate girders launching jetty. Foundation work.
this is a method used for foundation.
Positioning of liner pile with help of crane on pontoon. Driving temporary liner up to refusal with vibro hammer. Pile boring activity using piling rig.
Inside casing is done. By trimming
Pile
pipe,
concreting with tremie pipe.
trimming pipe is poured.
Substructure. Jacks. Placing secondary
pile
beams.
groups.
Placing bottom shuttering panels. Breaking and removal of pile head. Placing pile cap reinforcement.
For lift span, 15 pile groups.
Staging and shuttering arrangement for casting of P78 pile cap.
After this is totally, our piles are done.
Please.
I told it now lift span. How lift span is erected, everything you can able to see here properly.
Lift span girder assembly.
This video may not able to see anywhere in YouTube also anywhere. So you can clearly understand how it is launched.
Assembly is done using two numbers of 50 tons capacity gantries.
The primary members, secondary members got site welded in the closed huts. After that, it jacked to the certain height.
Assembly of launching girder.
This is a launching girder below it for the movement of the launch our lift span from A to our lift span location. Totally 4 launching girders, 2 at front and 2 at rear. was moved. Initially, that launching girder below will be moved. Pushing of launching girders.
In launching,
And I told her 2.65 degree of curvature. So alignment is to be done at each and every
aligning the
location.
launching girder in launching direction.
Because of 2.65 degree curvature, alignment is required. If alignment missed means we cannot move because it's 525 metric ton of weight of lift span is there. So at every pier, alignment is must and should for the launching girder. Now launching girder is done. Now launching girder will be stable. Over launching girder, now our lift span will be moved. You can
Pulling
clearly see
lift span
how
girder continuously using hydraulic jacks.
వెండి మరియు వజ్రాల మేకింగ్ ఛార్జీలపై 100% 24 క్యారెట్ల బంగారం బాల్ ఉచిత బహుమతి ఈ షోరూంలలో తీసుకెళ్లి చేతికి వస్తాయి.
launching girders will be moved. First front one, next back one. Above that, our lift span will be moved. Like that, will be moved from A to
Launching of
location
lift span girder in process.
It finally positioned to our lift span location. That is how lift span. This is approach girders, how it is moved.
Shifting of girder on motorized transport trolley.
Now erection of tower happened, and you can see the one more beauty, that entire bolted will be inside the tower. There is no projection of bolts, HFG bolts outside, because inside means we can reduce the corrosion. So initially the thought is to put the bolts is outside HFC, but later it made into inside. So bolt, no, there is, we cannot able to see bolts outside, inside only we can able to see. Now tower is done. Now erection of our machinery room on the top of the towers. And you can see at the wire ropes at each corner. One side it is staircase, other side is we are having lift to go to the top of the tower. One side it is lift, one side it is staircase is there.
Approach embankment work. E and track linking.
Finally track linking is done.
Provision of rail joint.
It's a final view. Once the train passed, whenever ship movement is required, that time we lift the bridge. Once bridge will be lifted, because of sheave, one side our bridge will be there, one side counterweight will be there. Counterweight will come down, bridge will be lifted to the top. You can able to see the counterweights coming down, bridge will be lifted to the top. And wall bridge also now required to open for the movement of the ship. Once ships are passed, both the bridges will be lowered. I told that 6 minutes is required for the no bridge to lift. Within 6 minutes, we can lift 17 meters height. I want to play last video.
It is.
So 1 minute, sir. Playing the last.
Second sir, 5 minutes to close them.
Sorry, sir, please.
జనాద్రిపై సంతతి కొరకై అహోరాత్రములు తపస్సు చేసే కేసరి కేసరి కుల సతి కడుపు పట్టగా జనించినాడుక అసమాన బలోద్ధతుడు సంయుతుడు అంజనాసుతుడు పవననందనుడు అరుణ కిరణముల హృదయాత్మి గని అది పండిన తీరని సూర్యమండలము పండితి కాలని వీళ్ళుడే తన దేహం నాటిన రవి మరుగై జగము చీకటై అది అమరేంద్రుడు కనరించి తన ఐరావతమది ఓడించి ఆంజనేయుని సమీపించి తన వజ్రాయుధము విసరగా అది పవననందనుని హనుముని తాకా చిందిన రక్త బిందువే విద్యుద్వేగంతో ధరణి స్థలి వంద కడలిలో చచ్చి వంద కడలి అట్టడుగున గల శ్రీరంగ శుద్ధి గర్భము చేరియట
Sir. Thank you so much, sir. Yes, sir. Any questions, please?
Complete Jagal sir. Complete Jagal sir. Hello.
Done, sir. Done, sir. Yes, sir.
Heartily congratulations, Jagal sir. Really highly appreciable. And today we are planning to a team of people. We are planning to come to see the first permanent bridge, old and new both, under direction of our Madam Padmaja garu and Sudhakar sir.
So congratulations, Chakradhar garu. It was a very nice presentation. So on behalf of our chairman, our honorary secretary, on all the office bearers here, and I congratulate you for the wonderful presentation that you have made. I wish you a great success in your career. We hope to see many more such wonders from you in Indian Railways. I thank you for having readily accepted the invitation and have given us a very good presentation. We have a part of the electrical presentation. Listen from you shortly. So thank you.
Our
so much,
council members, Cyril Mitrani garu have been to Rameshwaram and Dhanushkodi, and Chief Engineer Khagina Saab also here. Sir, kindly.
I had actually, I have seen this old bridge when I had gone to. Hello.
Yeah, continue, sir.
Hello, are you able to listen to me?
Audible, sir. Audible.
Ramana, are you able to listen to me?
Yeah, sir. Audible.
Sir, see, actually, I had been to Rameswaram, and then while going to Dhanushkoti, we have seen this old bridge. It's a fantastic mechanical, actually arrangement. But now, I am seeing through this the latest developments on this. Really, very good achievement by our Indian Railways. I congratulate Chakradhar for giving me a very good presentation to us. Thank you, Chakradhar.
Chakradhar sir, we are having a great engineer, Mr. Raghu Prasad here. He's also Additional Commissioner GHMC, and also Khagindar is there. Khagindar also unmute, please unmute. I think Mr. Raghu Prasad sir will tell a few words about this thing. Kindly.
Yes, sir.
Raghu Prasad.
Thank you, sir. Thank you, Chakradhar sir.
You have seen in TV. No problem.
Yeah.
Thank you so much, sir.
I saw the presentation. It is wonderful, sir. It's marvelous, and I congratulate you for giving this presentation to share views and what type of architecture they have done, and what is the thought behind this, and implementation hurdles, and everything is appreciable ultimately. I congratulate once again, sir. Thank you.
Thank you, sir.
Ramanaji, I just want to congratulate our Raghuji.
Yeah, thank you.
Okay, sir, Raghuji, I'm really happy that you have taken over as Malkasgiri Municipal Corporation Commissioner.
Thank you.
And in fact, I hail from that area. I live in that Vesro Nagar.
No,
So,
we are going to
really, I'm very happy that you have come to our area.
Yeah. Our area, sir. Sir, we are going to facilitate Raghu Prasad Saab and Dr. Rama and Satlik, kindly be line.
After 15th. After Sivaratri.
Yeah, Jubilant, sir. Now, Khagina Saab, our Chief Engineer, retired and dam safety.
Yeah, thank you, sir. Special congratulations to Chakradhar garu. Congratulations on promotion.
Okay, sir. Okay,
Sorry. Yeah. May I speak? Sorry.
Sir, one by one, sir. Can complete Khagina Saab. Then sir will go for question and answer. Kindly.
Yes, sir.
Sir, please tell your name and introduce, sir. Devkumar sir also from JNTU Antapur, from Andhra Pradesh State Center. Kindly. विश्वास जी बोल रहे हैं?
सर मैं श्रीनिवास बात कर रहा हूँ सर
बात कीजिए विश्वास साहब प्लीज
శ్రీనివాస్ గారు నేను శ్రీనివాస్ మాట్లాడుతున్నానండి
చెప్పండి సార్
Sir, I congratulate him for his presentation, and it is very good and knowledgeable. I wish him very success in his professional career. And
thank you,
one question I want to ask him about whether there is any bridge health monitoring systems provided in this or not. Only ammometers. He explained about only ammometers. But what about remaining bridge health monitoring systems? Is there anything provided or not?
No, sir, not yet. Now railway is planning for that monitoring system.
Okay.
Yes.
And one more question, sir. What is the grade of superstructure steel they are used in this?
For the substructure, it is
no superstructure.
Superstructure.
Plates, what is the grade of that superstructure grades?
E350, sir. B0. E350.
B350, yeah.
E350, sir. E350. B0.
Okay.
Fully killed.
Okay, sir. Thank you, sir. Thank you.
Sir, Devkumar,
Thank you,
sir,
sir.
Professor Devkumar from JNT Andhra Pradesh. Please kindly, sir, unmute yourself and
Yeah,
close it.
yeah. Good evening. Thank you for giving me opportunity, Chairman, sir, Telangana State Center. On behalf of Andhra Pradesh State Center, I appreciate Telangana State Center and the leadership of Ram Naik and our Ramesh, Rama, Brahmareddy Garu, Seeram Satyanarayan, sir. Everybody is there. Thank you. And I'm happy to see Padmaja Madam after a long time and Sudhakar, sir. Really appreciate the good activity, especially the latest technology our Indian scientists, engineers have developed. And all the demonstration is very good, and especially all the videos and explanation is very good. I appreciate Engineer Chakradhar Garu for excellent presentation.
Thank you, sir.
And
Thank you, Professor
ultimately,
Devkumar,
of
sir.
Andhra Pradesh State Center,
So thank you, sir. Devkumar, sir. We plan AP and Telangana. We plan together for a popular lecture, sir, regarding this only. So one Ramkishan Rao, sir, from ENC, calling from USA. Sir, please try to close in 2 minutes, sir. Ramkishan Rao, retired ENC from
I
USA.
take only 1 minute.
Yeah.
Okay. Are you listening me?
Yes, sir.
Are you hearing me? Hello?
Yes, sir. Continue, sir. Ramkishan Rao.
Okay. Congratulations to Mr. Chakradhar on nice presentation and nice work. I have one doubt. For a work
Yes,
of
sir.
such magnitude, why depend only on one supplier for supply of stainless steel? This is my one doubt. You can have multiple suppliers supplying at the same rate.
Sir, for that question, I'm not having proper answers. I will go through it and will get you back. I will get your contact and will
Okay, guys, you
give
can
the proper
have a
answer.
talk to your superiors.
Thank you,
Yes,
sir.
sir.
Because
Sure.
of such. Second one is I have a suggestion for design office.
Yes,
For
sir.
exterior girders, I prefer putting vertical stiffeners except over bearings on inner side. That is the practice followed in USA. So that you are avoiding packets for accumulation of dust and water. And it presents a neat look. Just one flat surface for your exterior girders.
You're telling
Put
for
all
approach
your
span, sir?
No, for anything, for any girder,
Okay.
why not place your vertical stiffeners except over bearings on interior side so that you present a flat surface on outside side. There are no pockets for accumulation of dust and water. You see, those are at a higher level. It is very difficult to clean them.
Yes,
that is the practice followed in USA. It looks like a cinema movie screen. Very neat. You have only two stiffeners, each over a bearing. Please, if any design people are here
Yes,
or
sir.
professors are here,
It is the
please consider
RDSO
this
designed,
aspect.
yes, sir. It is
No,
the
no, this
design.
is one thing commonly followed in USA,
Yes,
and I
sir, yes.
find the exterior girders very neat.
Thank you, sir.
Thank you,
Ramkishan
sir.
Garu, we are going to popular lecture from Telangana and Andhra Pradesh both together. Just now I have been to Chief Secretary, our engineer Ramkishan Garu is also coming. He told Sarfraz Ahmad to join with them. So let us before conclusion, one ENC from Karimnagar, Karim Saab Pancharat in 2 seconds. Unmute कीजिए. आप unmute कीजिए,
I would like to share, Chairman, sir, the kind permission of the Chairman.
Yeah.
May I talk for a few minutes?
Yeah, Khage Saab, go ahead. Khage Saab, go ahead.
Yeah, thank you. Yeah. Very good evening to all.
Yeah.
Special congratulations to Engineer Chakradhar Garu for such a nice presentation. And the
Yes, sir. Thank you, sir.
doubts expressed or they have fabricated, erected as per the designs, what I feel. And it is amazing technology. And that so engaged, he has achieved such a beautiful and such a gigantic bridge, in fact, and beautiful technology and nice presentation. Thank you so much, Chakradhar.
Thank you, sir.
At the
Thank you.
same time, actually, we used to fabricate gates, hoist bridges, and hoist equipments for irrigation projects, and which are waterborne surfaces, and we used to go for painting also, sandblasting and painting. And the technology which you have used, it is updated technology, and it is so nice to CEO presentation. Thank you so
This
much.
technology taken
that's-
from Spain, sir. Yes.
Thank you,
Spain
Shankar sir.
we
Oh,
adopted.
so nice. And special congratulations to Raghu sir also on his
Raghu sir.
promotion. Yeah.
Yes,
Thank you.
sir.
Thank you, one and all.
Thank you, thank you.
Sir, I would like to congratulate Mr. Chakravarti and also our Raghu Prasad ji and our chairman Garu, and also mainly our Padmaja, who we work together, and his husband who is here. Really, it is very honor to see this program. It's a big technical expertise here, and we are happy to, to be in this occasion. We would like to continue such programs in future. Especially, I would like to congratulate once more our Raghu Prasad ji, who has taken such a big
Thank you, sir.
implementation program by becoming a commissioner. He is very much needed to the society, who is highly integrity and honesty, and also hard-working type of personality. We would like to actually pray that he should be in the highest position in his future life and longevity of life and peace, and make the people to get more and more benefits, because that is such a big important
Thank you,
post.
Khalil sir. Thank you. Khalil sir, next we are going to festate. Chakra sir, we are proposing your name for Best Teaching Award from IA. With permission of all our attendees here, kindly may become member also. Now going for presentation to our Dr. Raghu Prasad and Dr. Rama and our Ashwini. Ashita from our Secretary of okay? I am requesting Honorable Secretary to propose. Rama. So, Ashita from our Prabhakar sir. Secretary sir, Secretary sister?
Sir.
So, Ashita, you are today's our chief guest, Raghu Prasad will first state, and our Brahmadi Garu, Chair Sharma. And Aisha Raju Garu, Sirin Garu, please comment. Rama sir, our chief engineer Padmaja madam, comment first state our. No. Sudhakar sir, both. Dama, madam. Dama. Madam, రండి both రండి వాళ్ళ సిస్టర్ ఇది మీరు అది కరెక్ట్ మధ్యలో రండి మేడం.
So on behalf of Chakradhar Garu, we are honoring her sister with the award. Congratulations to Chakradhar.
Thank you so much, sir. Thank you so much.
And Ashita. Meeting na? Media. Even Kalkar media. Okay? Yeah. Yeah. Follow.
So on behalf of our society.
Madam. Hearty congrats to Chakradhar once again.
Thank you so much, sir.
One more shawl.
Yeah.
One news bar cover and
One more shawl. ಎಲ್ಲ ಚೆನ್ನೈ So double Chakradhar and double congratulations.
Thank you so much, sir.
So congratulations on behalf of all of us.
Yeah. Congratulations.
Thank you so much, sir. Thank you. Thank you, sir.
Yeah. Okay. Next,
Next, our chief guest today's CN Raghuprasad, Assistant Chief Commissioner and GHMC, newly municipality Malkaji Kapra. Sir, Sadhan garu, congrats చెప్పండి. Sir, yes, sir. రండి సార్ సార్.
ల్యాప్టాప్ ఛార్జింగ్ పెట్టండి. బ్యాటరీ డౌన్.
రాజశేఖర్
ఛార్జింగ్
సార్ ఇది మై రూమ్మేట్.
ఎక్కడున్నా కనపడతాం.
Good. I am requesting Mr. Gopichand, General Secretary PC, please come and bless you. Come. Gopichand. Yeah.
Yeah.
No.
అందరూ ఒక్కొక్క ఫోటో.
Yeah. Commissioner గారు. దా బయన్ బయరా. రావణ కాచి.
గోడుపల్ మీ దగ్గర సార్.
అవునా. నేను ట్యాక్స్ ఎక్కువ లేట్ వచ్చింది. మా మైన్ ట్యాక్స్ ఎక్కువ. లేట్ వచ్చింది. Da, Sunada. Thank you. Madam, you know, రండి.
ఓకే సార్.
సెకండ్ ఫ్లోర్.
Okay.
I'm native of Varangal actually.
Oh. That's some R&B.
Yeah.
Okay.
Sir, I sir. Yeah.
ఇప్పుడు మేడం డాక్టర్
Visual call.
Ready?
Thanks, sir. Yeah.
Thank you.
Chief guest.
Dr. Rama.
Yeah.
Thank you. Thank you.
So,
అసలు మేడం
వాళ్ళ ఆఫీస్ పోతే వాళ్ళు
now I'm requesting our chief guest Raghuprasad sir to present our Dr. Rama, who got doctorate from JNT Hyderabad.
సబ్జెక్ట్ చెప్పలే రిమోట్ సెన్సింగ్.
Somewhere remote sensing.
Hot topic of
ప్రజెంట్ హాట్ టాపిక్.
Dr. Rama, congratulations. Dr. Rama.
Education department లో very rarely doctorates will come to doctorate.
హార్డ్ వర్కింగ్. ఇరిగేషన్.
Doctor in remote sensing.
all engineering department especially.
అంటే ఎడ్యుకేషన్ సైడ్ గెటింగ్ ఈజ్ డిఫరెంట్.
Okay, sir.
So, thanks, Sir. Now I am requesting Professor Mohiddin for a vote of thanks before our. Sorry, Padmaja Garu, our FIE, and always thinking about our IE, along with our Sudhakar sir, both of you welcome, sir. Please come. So thank you, sir. Secretary sir, we are requesting you to become member and
Sir, definitely, sir.
send thanks for
Sure,
the
sure,
event.
sure,
I'm
definitely.
requesting Professor Mohidin put a vote of thanks, propose vote of thanks.
Thank you, sir. Thank you, sir.
Thank you, Professor Dr. Ramana Nayak Bhanuti Garu, Chairman for Institution of Engineering. So today participated all the participants. Thank you. So very wonderful lecture given by Chakradhari Garu today's program on endowment lecture, and even Dr. Gopichand endowment lecture, and even family members. Thank you one and all. Thank you very much.
So now join for national anthem. Kindly stand up all of you and of the team of the kindly.
Thank you, sir. Thank you.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all of you. Thank you very much. We are again proposing a popular lecture in both states, in both both states, and in possible terminal also. We plan. Thank you. Good night, all of you. Special good night to.
You asked me to share this PPT.